Hi, boys and girls. Happy Monday. We're going to skip topic 6 and move ahead to topic 7, factors and multiples, one of my favorite 4th grade skills. So remember, factors are the numbers that multiply together to give you a product, right? And when you think of your multiplication facts, those are sort of a lot of those factors that you know, right? So, and you can also represent factors with arrays. So remember, arrays have rows and columns. And in a multiplication problem, that first number is the row and the second number, so the first number is the row and the second number is the number of columns, right? So if I was thinking of all of the factors of 6, I would want to think of all of the numbers that multiply together to give me 6, and we call those factor pairs. So my first factor pair would be 1 times 6, one row of 6. I could then flip that around and say 6 times 1, 6 rows of 1 column, okay? I also know, because I know my multiplication facts, I could do 2 times 3 to give me 6, 2 rows of 3 columns, 2 times 3. I can then sort of flip that around and say that it's 3 rows and 2 columns, okay? So 1 times 6, 6 times 1, 2 times 3, and 3 times 2 would be all of the factor pairs for 6. So let's look at this one with a little bit of a word problem. And oftentimes, if you get a word problem with factor pairs or factors, they're going to give you some sort of, an auditorium with seats, or you have to arrange rows and columns of seeds in a garden. Oftentimes, is in relation to some sort of array. So here, the music director is trying to find the best way to arrange the chairs for performance. The chairs must be arranged in a rectangular array. How many different ways can the chairs be arranged into a rectangular array? Use grids to show all the ways the chairs can be arranged. So there are 12 chairs. So essentially they're asking how many ways can you arrange 12, or how many factor pairs are there of 12? All right. So here they gave us also the grids. So you could do 1 times 12, one row of 12. You could then turn that around and do 12 times 1, 12 rows of 1. We also know 2 times 6 gives you 12. So 2 rows of 6 columns, or flip it around, 6 rows of 2 columns. We also know that 3 times 4 gives you 12. So 3 rows of 4 columns, or flip it around, 4 rows of 3 columns, okay? So then the question is, how many possibilities are there? How many factor pairs? 1, 2, 3, 4, 5, 6 possible ways, okay, that the 12 chairs can be arranged. So let's try one together. I have my pen. No, I don't. Here I do. We're on red. Awesome. So use the grid to find all the arrays and factor pairs of 9. So I know 1 is a factor of every number. So I'm going to do 1 times 9. I know I'm just going to sort of draw a line because we'll be here all day. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Square it up a little bit. Oh boy. So that's 1 times 9. 1 row of 9. Oh boy. Then we can flip that around, right? We could do 9 rows, 1 column. Sorry, my 9 up here looks like a 4. Okay. So let's do 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that's 9 rows, 1 column. I also know 3 times 3 gives me 9. So I could do 3 rows, 3 columns. And this actually makes a square array, right? If I flip this around, it's still going to be 3 times 3. So I'm not going to do it twice, okay? So let's try another one. We'll try another one. Maybe we won't try another one. Here we go. 14. So I'm going to start with 1 times 14 because we know 1 is a factor of every number. And 1 and that number are always going to be a factor of that number, if that makes sense. So hopefully I have 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So 1 row, 14 columns. Let's turn it the other way. It would be 14 rows and 1 column. So I'm going to do it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 rows, 1 column. I also know 2 times 7, and thinking about even and odds, all even numbers would have 2 as a factor. So 2 rows, 7 columns. So 1, 2, 3, 4, 5, 6, 7. And I'll just close that up. And now if we flip this around, 7 rows, 2 columns. So 1, 2, 3, 4, 5, 6, 7, 2 columns. All right, so those are all the factor pairs and arrays that match them for 14. Okay, let's try one more, and now we're just going to give digits. So we did 6 at the beginning, but we'll do it again. So I know you guys are, because this is a review, you're used to now listing them, and that's actually tomorrow's lesson. Today, they just want you to give the factor pair. So this is actually just like taking a step back from your knowledge for a moment. But it is quite possible in the future you can have a test question that asks for factor pairs and not to list the factors. So the factor pairs of 6 would be 1, and I think they use the words today, 1 and 6. I'm not going to write end every time. It would be 6 and 1. I'll just do a comma. And then 2 and 3 and 3 and 2. I think that's how they're going to present it to you today. They'll do 1 and 6, 6 and 1, 2 and 3, 3 and 2. 16, it'd be 1 and 16. And then we'll flip it. It would be 16 and 1. 16 is an even number, so I know 2 is a factor. 2 and 8. And then 8 and 2. I'm just flipping it. And then 4 times 4. And you don't have to flip that because it would be the same thing, right? So those would be all of the factor pairs. How many, if I had to count them, would be 1, 2, 3, 4, 5 factor pairs. 30, this is a good one. So 1 and 30. Oh boy. Flip it, 30 and 1. I know 5 times 6. 6 times 5. 3 times 10. 10 times 3. I also know that 30 is an even number, so 2 has to be a factor, 2 times something. And I already hear so many of you saying 2 times 15, and then turn it around, 15 times 2. So that one had a lot. Okay, so that's what you're doing today, everybody, 7-1. Have a great Monday, and I will see you tomorrow for listing factors, which is one of my favorite lessons. Have a great day. I'm patient enough. There we go.